Okay. Right, so what we've got is there are 4 rules that you need to know with logs. It's actually 5 rules, but we're only going to do 4 of them. And the first rule you already know. The first rule is all about changing from exponential form to logarithmic form. Okay? Then there are 3 more rules. Now, I might refer to them as Rule 1, Rule 2, Rule 3, Rule 4. So try and remember which rule is which, because as I'm going through, I'm saying use Rule 3 here, use Rule 4 here. Okay? And if I'm helping you individually, I might say to you, think about Rule number 2, think about Rule number 1. Okay? So that's how we're going to refer to them. So basically, what it is, rule number 2 says if I have let's say something like this, log base a of 2 plus log base a of 3, I can bring them together into one single logarithm to log base a of 2 times 3, which is log base a of 6. Okay? So I can take 2 logarithms and combine them into one logarithm. And the same for 3, which is basically saying if I take away some logarithms, then I can combine them, log base a of 3, by doing a division. So that would be log base a of 2 over 3. Okay, so again, I can take a double logarithm and turn it into a single logarithm. Also, if I have something like this, log base a of 6 squared, I can rewrite that as 2 log base a of 6. Okay? And remember, these rules work both ways. Sometimes you want to change a double logarithm to a single logarithm. Sometimes you want to split apart a single logarithm into 2 logarithms. It just depends on what problem you are faced with. Okay, now I'm going to prove these rules to you. It's very, very important that you understand where these rules come from. You don't need to remember these proofs, but I think it's very important that you understand that they're not just random made up things. So what we're going to do, I'm going to write out 2 exponential equations. I'm going to write out a to the power of x is equal to b, and I'm going to write out a to the power of y is equal to c. I'm going to use, so these are exponential, I'm going to use rule number 1 to change them to logarithmic. So that's going to be x equals log base a of b, and y is equal to log base a of c. Okay? Now, what I'm going to do is I am going to, so I've got equation 1 and equation 2 in the exponential form. I'm going to multiply those 2 equations together. So I get a to the x times a to the y is equal to bc. Now use the rules of indices. The left-hand side simplifies to a to the x plus y equals bc. Now again, use the rules of the first rule of logs, which says that x plus y must be equal to log base a of bc. But I already know what x and y are equal to. X is equal to log base a of b, and y is log base a of c, so that is equal to log base a of bc. So that is the second rule of logs proved. Okay, I can combine 2 logarithms into a single logarithm. If I'm adding, I'll just multiply what is in the logs. Okay, so that is that rule proved. I can prove the third rule of logs in very much a similar way. Instead of timesing equation 1 and equation 2, I'm going to divide equation 1 and equation 2. So I'm going to get a to the x over a to the y is equal to b over c. And using the rules of indices, that means that we get a to the x minus y is equal to b over c. Use the first rule of logs, x minus y equals log base a of b over c. And I already know what x and y are. Log base a of b minus log base a of c is equal to log base a of b over c. There is the second rule proved. So again, if I've got a subtraction of logs with the same base, I can bring them together into a single logarithm by dividing off the answers of what's in the log, okay? So that proves rule number 3. What about rule number 4? Rule number 4 says what happens if you have something like this. Log base a b to the power of n. Okay. Now what we can do here is we can say that is log base a of b times b times b times b, and we'll be multiplying b by itself n times. Okay. Now, using rule number 2 backwards, I can take the single logarithm and split it apart into log base a of b plus log base a of b plus log base a of b, and I will be adding them together. N times. Well, instead of adding them together n times, what I can do is just do n times log base ab. So it becomes n log base ab. So log base a of b to the n is equal to n log base a of b. I have proved rule number 4 there as well. Okay, see, you don't need to remember these proofs, but I just wanted you to be convinced that they make sense. Okay. What you need to be able to do is use them. Okay, you need to be able to combine these logarithms into a single logarithm. Okay, so here's how we do it. I'm going to use rule number 2 to write log base 2 of 35 minus a half log base 2 of 3. So I combined them together using rule number 2. Now I'm going to use rule number 4. Log base 2 of 35 minus log base 2 of 3 to the power of a half. And I know that 3 to the power of a half, because I know my rules of indices, is the square root of 3. Now I'm going to use rule number 3. That will become log base 2 of 35 over root 3. And there is my answer. I've combined all of this into a single logarithm. If you want to, you can rationalize the denominator of that as well. But it's okay as it is, to be fair. Now, what about B? B is tricky. Now watch this carefully. We can't bring together B just yet because 3 is not written as a log base 2. What we need to do is write it as a log base 2. So watch this little trick. I'm going to say log base 2 of something is equal to 3. Okay? So let's call that something x. Use exponential form. So change that into 2 to the 3 equals x. That means x must be equal to 8, which means log base 2 of 8 is equal to 3. So what I'm going to do is I'm going to change that 3 to log base 2 of 8 and now take away log base 2 of 5. Okay? Now I can use the third rule of logs. I'm going to get log base 2 of 8 over 5, which is log base 2 of 1.6. Okay, I've achieved my goal. I've written this as a single logarithm. Okay, let's just do one more example of something like that. Maybe you get something like this: 1 plus 2 log base 3 of 4, let's say. Well, first things first, we can do 1 plus log base 3 of 4 squared, which is 16. Now we need to write 1 as a log base 3. So we're going to say log base 3 of something is equal to 1. Well, that means 3 to the 1 equals x, x equals 3. So log base 3 of 3 equals 1. So we're going to do log base 3 of 3 plus log base 3 of 16. Now I can use rule number 2. Log base 3 of 48 is a single logarithm. Okay, changing something that's not a single logarithm into a single logarithm. Okay. Now, sometimes you see a situation where you don't have a base written. Log 1000. If you don't see a base written, it means that the base is 10. So that is the same as log base 10 of 1000. We never write this. We just write this, but it's what we mean, okay? So what is that equal to? X equals log base 10 of 1000. Change it into exponential. It means 10 to the power of x equals 1000. X is equal to 3. So log base 10 of 1000. So log 1000 is equal to 3. Okay. If there is no base written there, then the base is 10. Let's say you get something like this: 1 plus log of 3. Okay, bring together as a single logarithm. Let's just delete this for a second. What I need to do is write 1 as a log base 10. So log of something equals 1. Well, that means that 10 to the power of 1 equals x, so x equals 10. Rewrite this as log 10 plus log 3. Now use rule number 2, that equals to log 30. Okay? The base is 10 if it's not written. Alright? Right, now have a go at practicing these rules yourself. So stop the video and have a go. Okay, so here we've got to find out the value of x. Here's what we do. We're going to say log base of x over 7, that's used rule 2 there on the left hand side, is equal to log 4, I've used rule 4 on the right hand side. Now I can cancel off the logs because the base is the same. So x over 7 equals 4, so x equals 28. Okay. Let's do B. I'm going to use rule number 4, log base of 25 plus log x equals log 8. Twice I used rule number 4 there. Log x equals log 8 minus log 25. Log x equals log of 8 over 25. Now I can simply cancel off the logs and see that x is equal to 8 over 25. Okay, let's do another. Log base 2 of x plus 3 is equal to log base 2 of 81. I used rule number 4 there on the right hand side. Log base 2 of x plus, I need to write 3 as a log base 2. So I've shown you how to do that many times. So hopefully you will agree with me. That's log base 2 of 8. 3 is equal to log base 2 of 8. And that's equal to log base 2 of 81. Log base 2 of x equals log base 2 of 81 minus log base 2 of 8. Log base 2 of x equals log base 2 of 81 over 8. That's rule number 3 there. Cancel off the logs because the base is the same. X equals 81 over 8. Okay, whenever you have a log question, it's all about using those 4 rules. If you're ever going to do something using logs and you're not using those 4 rules, then you're doing it wrong. Okay, and when I try to help students, they all say, oh, can I do this? Can I do that? Use the rules. Use the rules. Okay, the rules are there to help you. There's no other rules. You just use them. Okay, let's do D. I'm going to use rule 4 here. Log x squared minus, I'm going to need to write 1 as a log in base 10. So that's going to be log 10. Again, I've shown you how to do that many times. So that's log x squared minus log 10 is 1. Okay, equals log of 36 to the half, which is the square root of 36. So that's log 6. Okay, I used rule 4 there, and then some rule of indices. So what do we get? We get log of x squared equals log 6 plus log 10. Log of x squared equals log 60. Cancel off the logs. X squared equals 60. X equals the square root of 60. Okay, which is what? 2 root 15 if we simplify the third. 2 root 15. Now, actually, you might be saying, okay, couldn't it be plus or minus? Well, actually, no. Logs can't take a negative value of x. Okay, and you'll see why that in a future video. Okay, final little piece of work here in this video. Remember, the rules work in both directions. The rules work both ways. Okay, so here you're going to use some of these log rules backwards. You are told that log base a of 6 equals x and log base a of 2 equals y. So we will need to write an expression in terms of x and y for the following. Well, I can rewrite log base a of 18 as log base a of 6 plus log base a of 3. Well, log base a of 6 is x, and log base a of... that is meant to be 3, and that's meant to be 2, and that's meant to be a half. Sorry about that. So that becomes x plus... wrong colour. X plus y. Okay, log base a of 18 is x plus y given these facts here. Okay, just get rid of that. Just write the answer again, x plus y. Okay, log base a of 2 can be written as log base a of 6 minus log base a of 3. So that is equal to x minus y. Log base a of a half can be written as log base a of 3 minus log base a of 6, which is equal to y minus x. Okay. What about D? Well, one thing I notice here is I can rewrite this as log base a of 6 squared. Use rule number 4, I can rewrite that as 2 log base a of 6. Log base a of 6 is x. So that has got to be equal to 2x.